I'm Michael McNulty. Thanks for the intro. Yeah, I'm a partner at Citron Cooperman. You might know McNulty and Associates. We've been around a long time. I've been doing price to win analysis for 25 years. And a lot of my team is on today. And my background is in engineering. So we're going to be talking about systems engineering and design to cost today and how it helps companies when they're trying to get a proposal out the door and win. And I'll talk a little bit about how we see design to cost being used today in solutioning deals in the marketplace, and how a little bit about how we fit into design to cost activities and price to win analysis, and how all that stuff fits together if you're not on that side of the coin, or if you're interested about it, want to know more about it. So we'll talk about design to cost today and introduce that if it's something you haven't seen a lot of. If you're not an engineer or systems engineer, you probably haven't seen a lot of it, but the common sense of it will make a lot of sense to you. It's a common sense idea applied to systems engineering, which we'll talk a little bit about today. A couple of key items that I want you to take away as we're working is what I'm going to talk about most of the day is the proposal phase because of the audience. So when you're designing, when you're writing a proposal, and what activities you need to undertake related to design to cost today. And I'll talk a little bit about analysis alternatives. I'll define all these things, and cost to win analysis and price to win analysis, give you a couple of examples, and then talk about execution on the program a little bit after you win, and then wrap it up and we can take questions. Okay, so what's this all about? So design to cost is really a common sense sort of approach to systems engineering. If you're an engineer, if you've been running around systems engineering at all, this is what they call the systems engineering V, which I won't bore you with a lot of details on, but basically it's the front end of a project all the way through design and production and operations and maintenance of a system. And if you're gonna write a proposal for a complex solution kind of project, you've got to worry about some things. If you're not careful, the program can blow up on you and you have disaster. And that's why we're trying to avoid that. And I'll tell you what that is. So any kind of complex solutioning deal, if you don't do some early work, which I'm going to talk about today, some early work to understand what alternatives you have, and which one you're going to go with. In other words, which is the way we're going to go. Instead of, you can't go every way at once. You have to pick a way in your proposal and go that way. And what are the costs associated with the way you're going? If you don't do that work early and well, it can really blow up on you. We engineers are bad about cost creep, designing gold-plated things, all that kind of stuff, things that we're interested in. And if we don't have some structure to help us go through the process, well, things can get out of control. So it's very important to do this work. That's the kind of common sense of it. It naturally increases your chances of winning a proposal because it has a lot of discipline to it. It ultimately should end up in helping you have a profitable and a good program that performs well with high customer satisfaction. And it's relevant. I'll talk today a little bit. I'll give you a couple of examples. It's relevant to any big solutioning deal. So it doesn't have to be, I'll give you an example of a UAV, but then I'm also going to give you an example of a big IT system. So everything's got IT in it today, software and that kind of stuff. I'll talk about that too. So any kind of solutioning deal that's complex and involves a lot of stakeholders lends itself well to this concept of design to cost, which is the idea of designing your system with cost in mind over time so that you have control of it as you go. So there's a couple of pieces to this. Obviously, like a lot of things related to business development, capture, and proposals, start early, right? So you want to leverage the beginning of the life cycle of design to cost. I'll talk a lot about this today, but it turns out that about 80%, by the time you win a program, about 80% of the cost decisions you've made are baked into the bid. So you've made a choice on what you're submitting, what you said to the government you're going to do, when you're going to do it, your staffing plan, your material, your labor, all of the stuff that you're going to do, when you're going to do it, your program plan, all that stuff that's in the proposal, and you've signed a contract. You won, great. So all the costs associated with that are baked into the program, and we'll talk a little bit about that today. So it's an important item, because if that gets out of whack, you've got some problems. And we're going to look at a couple of activities that go on during the design to cost process. Analysis of alternatives, choosing the path you're going to go on, the costs associated with that. We'll talk a little bit about price to win analysis. We'll talk a little bit about program cost after winning. Also, one of the things I want to point out here is you can never lose sight of the competition. You're trying to win a proposal. So are your competitors. They're smart. They're going to do a lot of the same things I'm talking about today. So imagine, just like you always do, if you're working on a proposal, they're over there working on their proposal. And there's some other things they're probably doing too, like what we're going to talk about today, which are related to design to cost. So they're coming, right, to win, and they want to make sure you don't win. And so we just always have to keep them in mind as we're working. Okay. This is an overall design to cost chart that talks about the life cycle of design to cost. The early days, or the original idea of design to cost, doesn't really contemplate writing a proposal. It contemplates designing and building something. But we've got to write a proposal before we win, right? And so the early part of design to cost is what we call the proposal phase, which is shown here. And you can see it against the systems engineering phases up top, and the government acquisition life cycle down bottom, which are standard items that everybody would probably recognize. So this part of the graph or picture shows you what's going to go on during the proposal phase, which is what we're most interested in today. And then this is the execution phase after you win. Take a look at this blue line. This is the committed cost curve. The committed cost curve, like I mentioned, by the time you've won, you're development of the RFP, and the time the proposal is awarded, the contract's awarded, you baked in a lot of those costs. And I'll talk about that. That'll become obvious as we go. And these are the things that we're going to talk a little bit about today as we go. Okay, analysis of alternatives. So we're gonna design and build something. All right, and the government says what they want. They're industry day and market assessment, and they're talking about what they need. And early on, you don't really know what they need. Maybe they don't know what they need, but that's starting to become clear. So early on, this is an example of the government needs to move people or cargo a long way. Just as something to think about here. And then you start off thinking, well, maybe we can use an airplane for that because we have to go across oceans. And then they say, no, we're not going to go across. This is all going to be CONUS. Maybe we can use trucks for this. You say, no, we don't need trucks. We're actually, this is probably a sedan or a car kind of solution for the problem. Okay, good. And then within that sedan or car solution, now there's different choices. Of course, there's a lot of different cars out there, a lot of different ways to go. But I want to point out that this step, which is a simple step, but I want to point out that this step is very important, because engineers, we love to keep the balls in the air for a long time. And so yes, we have lots of choices, but at the end of the day, you've got to make some choices, and you've got to come down to the alternative you choose. And you have to choose something that's going to fit in this cost, along this cost line. All right, so cost is always something that has to be taken into account while you're working. Okay. Here is a first look at the cost to win analysis, what we call the cost to win analysis step. It's a step in the overall design to cost process, and it's designed to get us, now we're past alternative analysis of alternatives. We've chosen a car, and we're going to dig in here, and we're going to decide what kind of car, and we're going to decide, how that plays out. Again, cost comes into play right away. I'd love to have a nice Porsche 911 here, but the cost profile of the program won't allow it. Right? It's just not gonna work. And you have to be careful here too, because when you're working inside an engineering group that's working on a proposal, if they're not careful and everybody's not on board, this can happen. This cost curve can happen, even while you're not paying attention. A couple of people get changed out on the job, or you have subcontractors doing part of the work, or so on and so forth, or there's a joint venture or something. All of a sudden, this straightforward sedan design, you get to some internal reviews for the proposal, and now you're on this path, and you don't even realize it, and you've lost weeks. And so you've got to there's got to be a lot of discipline here. And this is something that a lot of you won't necessarily do in your day-to-day, but I want to make you aware of it so that you know what's going on in engineering groups that are doing this kind of work. Okay. And there's lots of stakeholders here, right? All right, let's talk about price to win for a minute. So we're price to win folks. We do lots and lots of price to win, 65 to 80 price to win analyses a year. Kind of shameless plug. We are very focused on solution-based price to win analysis. We do all kinds of price to win analysis, but solution-based price to win, which is looking at the competition. All price to win is really looking at the competition. So you're looking at the competition in the price to win analysis. How will they solve the problem? What kind of car or truck are they bringing to the table on this particular example? And so that analysis will be looking at all the requirements. We'll be looking at the program, be looking at the customer, their buying habits, their buying behaviors, and all that kind of good stuff. And then it's going to break the project down, kind of like the cost analysis, into its individual parts and components that comprise the competitor's solutions, the three solutions that we have here. And in the example we have here, we have the solution C being picked, which is similar to what you saw in the cost analysis solution. And then you see a price to win curve, which, as you might not be surprised to see, is lower than the cost curve of the program. That's a competitive position, right? So that's going to come back to, when price to win analysis is done, that's going to come back to the capture team and the proposal team, and they're going to need to get to those numbers. They're going to try to get to those numbers in the cost side of their proposal, and of course that will affect the technical side of the proposal because they go together, right? They go together. So keep in mind that price to win analysis is another step in the overall process. And we'll talk about how it impacts design to cost as we go. Okay, so back to a car. In this case, we show the undisciplined no cost analysis being done on the left, and we see a disciplined price to win analysis being done on the right. And when you try to reconcile those as you're writing your proposal, you're going to have a big problem, right? You're having an explosion because the guys on the left are designing this thing that won't fit into the cost curves of the project. And the price to win analysis, which is not wrong, is taking a very good look at the competition. It's got the car, it's got all the costs, it's got it at price, and this is just not going to work. And you can't reconcile it, and now you've run out of time, and that's where the disaster comes in. And if you've been around a while, you've seen this. And so you want to get way ahead of it. And here's a quick high-level example of kind of doing it right. On the left, you have the cost analysis being broken down into the individual parts of the car, the design, the production, the labor, the materials, and the individual costs. The reason I'm breaking it down like this, and you'll see as we go, is good price to win analysis delves way down into the pieces and parts of the price, the individual components that comprise the total evaluated price. And so a good price to win analysis is going to dig into all of that, and the good cost analysis, as we talked about, is naturally going to be working at that level. And so they can be rationalized, they can be reconciled and optimized right here. And so this team can actually achieve the price to win analysis that's coming in. Now, the price to win analysis is sometimes done internally, and sometimes it's done externally. We do, obviously, external price to win analysis. But if you work with any of the big outfits, they all have internal price to win teams, and they should. We work with them a lot. But the point is, all good price to win analysis is focused on the competition and their solution and their likely technical scores and their color scores and their likely price. And then that's going to come in and have to be dealt with by the capture team, the proposal team, to get them home. And so when these things are too far out of bed, you've got trouble. All right. Here's backing up again a little bit to give you an overall picture to orient you to the
Partial
overall
and
situation.
timely, effective, integrated, secure.
I'm sorry, we're getting some chatter. Okay, go ahead, please. All right. So here's a picture of the overall design to cost program process again. But in this case, notice I've grayed out the proposal activities. Those are done. We've won. Congratulations. And now we're in execution. So we're in the design to cost execution phase. We're still designing the car. Okay. You didn't design the car in the proposal. You did a lot of stuff to get ready to design the car. The government's going to pay you to do the design. All the stuff in the proposal talks about what you're going to do in the design phase, who's going to work on it, how long it's going to take, what kind of material, an IMP and an IMS, and all of the stuff that's in the proposal that talks about all the wonderful things that you'll do once you're under contract, but you haven't designed anything yet. And so now we're on execution, and now we're going through design. And here's where there's another big problem that I'll just make everybody aware of if you end up having to work with this. A lot of times the people that won the program, they're not around anymore. They wrote the proposal a year ago, 2 years ago sometimes. Now it's been awarded and people are picking it up. And some of those people are gone, or all of those people are gone. The company won the program and now they're trying to execute the program. Great. And now we've got a few $100 million for this program. And the discipline that was in here, the discipline that was put in the proposal, and all the hard work and the cost analysis and everything I've been talking about, that's kind of gone out the window if nobody picks it up and grabs it and gets their arms around it again. And it won't be very long if you're not careful. The engineers will go up here. They'll go right up into that new cost curve because everybody wants the 911. Everybody wants the Porsche, right? That's fun. And if you're not careful, you got a program that's out of bed right away. So I'll just let you know that this is the overall picture of design to cost and why it's so important in systems engineering and cost control and program management. Okay, so here's an example of this. So now I'm back in execution. Okay, I'm back in here. I'm sorry, back in proposal. I'm out of execution. I'm back in here in proposal, and we're trying to win a proposal. Okay, so now here's an example. So this is an example of a cost to win phase of a UAV development and production program. So the engineering team is looking at this and they're doing their design to cost work. They're looking at this particular project. They're going to take this UAV. They're going to upgrade this Global Hawk, and then they're going to produce a bunch of them. And there's the requirements, and it's going to be optimized. There's going to be an affordable solution developed. And how will the engineering team figure this out? What do you do? Well, normally what they'll do is the systems engineers and the individual engineers for the components and parts will work together to build something like this work breakdown structure that's shown here in the middle. We use a bunch of engineering tools to help us do this and break the individual program down to its parts, right? So it's work breakdown structure pieces. In this case, since it's a UAV, you might imagine it has things like its fixed equipment, avionics, guidance and control, comms, navigation, and so on. Okay, that's great, but what does everything cost? That's what we're interested in. So over here, we're starting to break down the individual components into their cost. How many hours and what kind of labor categories are going to be used to build it? What's the material cost for the program? And now we're getting total costs for the various systems and subsystems, including the production of those items for this program. And you can, once you've done this and you've done this well, you can really look at this project a bunch of different ways. You know, you can look at the development costs, the production costs. You can slice and dice this a million different ways. And I'll let you know, you're going to run into some. The people that do this are going to run into some headwind here, which is natural, just what you'd expect, because you've got to work at the subsystem level. So this program is a multi-billion-dollar program, and that sounds great, except that's not how each part. That's not what each part costs, of course, right? So how much is the avionics? How much is the aerospace aero guidance and control piece? Well, I don't know, but I mean, once those cost bogeys are assigned, then the teams and stakeholders that go off to work on those and work within those cost envelopes, they need to stay there. They can't exceed them. And people will come back and say, whoa, 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 whoa. Smart people that know what they're talking about will come back and say, I can't do comms and navigation for $100 million. It sounds like I can, but I can't. Here's why. And they'll come back and they'll show you what the problem is. Okay, they're right. Okay, now what? So then you get into working the trade space up and down the project to reallocate costs associated with all the activities so that you can meet the overall budget envelope for the program. So I won't drill into that too deeply, but that's just the kinds of things that pop up as teams are working on this part of the work. Here's another example. As I mentioned, this design to cost work is highly relevant to any complex solutioning deal. Could be a UAV or it could be an IT system. And it could be an installed IT system, a system that's been around for a long time and it's all over the place, like the Army Corps of Engineers IT system, which is all over the place. And if you've been around a while, you probably worked on that proposal. And you know, there's 1,900 locations, and they don't tell you how many people it takes to take care of that. You got to figure that out. And so that kind of a project, if you wait to the last minute to do the, you know, how you're going to approach it, you're going to put everybody in one place, you're going to put everybody in a hub and spoke kind of situation, all of that, how are you going to do all that, the costs associated with that? If you wait till the last minute to try to figure that out, you're going to be in trouble. And so, you know, again, this approach lends itself well to all kinds of solution kinds of deals. And so we come in and work the cost to win analysis with teams early on. And this, in this IT example, you can see you've got a OCONUS Army network, you know, 11,000 users. You know, we're back to our parametric modeling. We use the SEER suite of tools. On the previous example for the UAV, we'd use SEER H. Here we'd use SEER for IT. And again, we're breaking the program down into its individual parts, NOx, SOx. This is the AFRICOM look. You can look at the virtualization, shared services, all kinds of pieces and parts and how the system works, and then what are the associated costs with it. And this is at the design phase. This isn't actually doing the work yet. This is going to go in the proposal. And again, you'll go through the horse trading of, you know, what costs are associated with which parts, so that we can stay inside the individual cost envelopes and the overall cost envelope for the program, so we can move forward in a good disciplined manner toward winning the proposal. And then comes price to win again. So price to win analysis, again, whether it's done internally or externally, and this is where we come in. Often we'll do the cost analysis and then go away for a while and then come back and do the price to win analysis. This time, the price to win analysis, as I said, is always aimed at the competition. It's not aimed at this design right here. It's not aimed at that internal work. It's aimed at the competition now. So this is the UAV again. And we're aimed at 3 competitors that are going to bid this job and try to win. So now we're breaking the program down again, just like we would cost analysis phase. And we're going to use the same suite of tools to break the program down as if we are your competition, and do the cost analysis over here. Now we're working at price. Cost is cost, right? You know, the direct labor, the materials, recurring, non-recurring engineering, indirect costs, overhead, G&A, fringe, and all. It doesn't have any fee on it. It doesn't have the treatment of the team and how all that stuff works together towards price. And so now we're working at the price level for price to win, because you put a price in a proposal. You put costs in a proposal, but you ultimately have to put your price in, what your bid price is. And so the government evaluates things at the total evaluated price level. And so that's what price to win gets to. And from the estimate of what the total evaluated price will be for the different competitors, a price to win recommendation can be made back to the team. So an example here would be, we're seeing TEPs, or total evaluated prices, from 7.5 to 7.9 billion. After the various price to win maneuvers are made, the bottom line is the recommendation to the team is get below 7.1 billion. Okay, great. And now that's something that the team can work with, but they can't really work at the $7.1 billion level, right? It's too big of a number. It's over 10 years or so on and so forth. So again, they've got to go back to the individual parts and pieces and you know and look at the costs associated with the project at the individual price cost level and bring those to price and see if they can fit under the overall price to win recommendation. And in this particular case, it looks like they're going to be okay because they're in the, 4 billion plus, 2 billion. And then you start putting things like fee and G&A and all that good stuff on. And this recommendation is in the 7 range, right? But let's flip the script a little bit. Let's say these guys over here are at the $7 billion level. This comes in at 7. We haven't even put fee on this thing yet. There's no G&A, there's no treatment of subcontractors, none of that kind of stuff is on there. You're never going to get home. You're probably going to be at $9 billion. This program's going to explode. You're not going to win. You've got to fix this. And so getting ahead of it early so that the early cost to win analysis is done and the early price to win analysis is done and those are reconciled, that's where you're now on a path to getting a super proposal out the door that's a winner. So all of this, like I talked about, is designed to have a really good design function that's got cost in mind all the way through. We talked about the proposal phase and the analysis of alternatives, the cost to win analysis and price to win analysis, and how all those things fit together. And also what happens once you win the program and execute the program. Now you're on a cost profile and a price profile with the government that everybody can work to, and you can stay on track and have a successful program. And of course, never losing sight of the competitors throughout the process, all the way up to award. Let me stop there and take questions.
Yeah, I had 2 questions.
Yeah, go ahead, please.
Yeah, so one, kind of going back to the beginning, you had mentioned that by the proposal phase, we'd want to have like 80% of our costs accounted for, something along that line. And I was,
yeah, well, you kind of can't help it. They're already, you're kind of signing up for those costs, but go ahead. Yeah.
Well, I would think the opposite. I think you'd want to have 100% of your costs allocated for it in the proposal.
Yeah, that's probably closer to right. Yeah, it's at least 80. It's probably 100. Yeah, because you've talked about everything you're going to do. What we're trying to indicate is there's maybe some flexibility, but you don't have much.
Okay, I think I'm following. More about the performance than the actual like build cost.
Yeah, right.
Okay. And then the other question is, on this last slide, you had like our competitor one was 7.7 billion, but there was a 5% premium. And so the actual price to win was like 7.1 billion. Is that premium because they're delivering like a more technically capable product, both products still being in spec, but maybe they're offering like a premium version? So if we're going to offer a lesser product, we would want to charge that 5% less to account for that lesser product.
Yeah, the 5% less. We use the term premium to beat. It's a term of art. We use it quite a bit in price to win analysis. But yeah, you're really, it's the idea that you want to get under the competitor, so you have some room under the competitor.
Yeah,
that's the idea.
It's going to be related
it's
to
a model.
color scores.
Yeah, go ahead, John. This is John
say,
Anderson on my team. Go ahead, John.
Yeah, I was going to say it's going to be related to those color scores. If you notice that 5% was applied to the team that was rated as being blue. So you have to make some sort of independent judgment of how you're going to score. I know if you guys work for typical capture teams, you think every proposal you submit is blue. But you have to have some sort of independent, like, okay, how do we think we're really going to do? Are we going to have the best solution, or are we going to be purple, or are we going to have some green in there? So you're trying to kind of position accordingly in a best value environment.
Makes sense. Thank you.
You found one.
Yeah, but we can have some food happens the bag.
Yeah,
Phone bag.
yeah, it'll work.
Yeah.
Okay, I have two questions in the Q&A chat. The first question is, how do you help support design to cost when the requirements from the government are vague?
That's a great question. That happens all the time. And the good news is that you've got the same problem everybody else does, right? What you've got to do is you've got to do for any kind of design, you've got to do the best you can to lay the design in from the government requirements, from the standpoint of from the RFI standpoint, through the draft RFP, through the release of technical specs and requirements, the best you can against the RFP. Sometimes the RFP is not well defined, and that's a problem, but it's also potentially an opportunity. A lot of times those are going to be cost reimbursable type contracts. And so, you have to kind of think through your design strategy and what will win, but what you'll do after award if the government comes back and says, no, that's not what we meant. Well, that's not what you said. So then you have to be ready to work through that with engineering changes and that kind of stuff. So, I mean, maybe John or Jared can give us more color on handling a vague requirements document.
Yeah, and I think at the beginning, it's really about choosing roughly the right path. It's not about when the government's talking holistically about a new capability they want. It's not really about whether you're choosing the normal sedan or the Porsche. It's about not choosing the plane. It's about looking at the budget and buying habits, similar solutions that may be out there, and making sure you at least start down the right path. So you're not too far out of bed, so that as the requirements start to mature, you're now, within a reasonable range that you can operate and adjust to.
Okay. The next question is, how do you handle last minute changes?
John, you want to stay with that?
Yeah, and that's always a challenge. And we're very aware of that as we work. And I know a lot of, besides us, a lot of price to win analysts are always very aware of amendments and Q&As that can change the scope, and you sort of have to state your assumptions, work that out with the team so that you're operating from the same assumption base, and then be prepared to make adjustments. And while we do, we strive to be very independent. I think, even at larger firms that have internal capabilities, they strive to be independent too. But you do sometimes have to talk through, like, here's the baseline assumptions I'm using as I look at these RFP documents, and make sure you're in agreement with the capture team. And that's not a bad thing to do, because sometimes it can bring up uncertainty that the team may want to look at in other ways. Maybe they want to ask a question, maybe they want to talk to subs, but unearthing that early on can be helpful.
Okay. Next question is, what happens when executives want to go too low and the design to cost doesn't support the design?
Well, yeah, and everybody's got a war story. I do think that it is a lot of it is trying to provide some discipline into the process, because those same executives, part of the reason they kind of get in that mode is they get used to the idea that, these teams bring me these expensive solutions and I can say cut 30%, and they somehow manage to do it. Well, okay. So if you've got that discipline process from the beginning, then the ramifications of trying to make big cuts, later on, you can show, and say, hey, no, the budget called, so the unit price of this thing is going to be $200 million. So, it doesn't mean we should bid 200 million, but it means 100 million is probably not right. And it means 400 million is probably not right. So that is, it is about making sure you've got a discipline to have informed conversations with executives and the team.
Okay.
Hi,
Yeah, I'd like to go a little further on that if I could. If I might, I want to show you something that we do a lot right here. Can you see that still? Did I lose the screen? Can you see it? I can't tell.
No, we can't. We're not sharing anything.
Oh, let's see. Hang on. Let me share my screen again. You see that?
It's yep. Yeah, we can. That's our team. You can see the team. Our team slide.
Okay, good. So I wanted to show this. So to the question of talking with executives and even to other stakeholders, subcontractors, teammates, and so on, this kind of work right here is absolutely essential because out of all this, you might imagine, right? There are things like confidence curves that can be built, which indicate the likelihood that you're going to be able to do this at the cost and prices that you have in your model. And confidence curves are S curves. And if you get too far away from really the midpoint, the left of the midpoint, they start to blow up. And having the data in your analysis to help you work through the problem is very, very important for not only your team to keep you on track, but it's also very compelling when you're working with executives because you've done your homework and you can show them where the program can go and where it can't go.
Yeah, and one even a little further, it's really important to do this early because once the team, once you know IPTs or whatever, however you are organized, start coming back. Once the common navigation guy comes back, he spent the last month, he's got a solution, it's all priced up. Well, if he's way out of bed with his price, then you're sort of forcing them to kind of redo everything, and they probably have become emotionally attached to what they're doing. So
yeah, and you're out of time.
You're out of time. So you want to kind of lay things out. Now you have to adjust, and Michael's very clear on that because thinking you're going to get all these targets, every subsystem target exactly right from at the very beginning is unrealistic.
Right.
But you can start to break these things down. And well, the comms should be this percentage of the thing, and work through it to the point that now they're starting with a number at a very low level, and they can start to think, well, okay, well, here are the receivers I can use. Here are the antennas I can use. Is that going to work? Or is that a major problem? I need to go up to an engineering board. Or can I work through this at this level? And you're not trying to stop having to do some rework towards the end. You're trying to stop the issue of you're way out of bed and you're just like, having to do massive changes right at the end. And you wind up making mistakes and your proposal doesn't close properly and then you get a bunch of ENs and it's not great.
Okay, we have another question for junior to mid-level proposal coordinators that want to learn more about price to win and cost analysis. What are your recommendations for where to start? Are there any resources you would recommend?
Good question. I mean, it's always something that we're willing to talk with people about early on. We don't have a training course if that's what you're looking for. And I don't really have one that I recommend right now. It's one of those things that's kind of hard to teach. But we're definitely willing to chat with people and see where they are and what they are interested in learning about and talking with them. And maybe we can send them in the right direction if we can't help them. I don't have a better answer. John or Jared, do you have a better answer?
Yeah, I think that's right. I mean, we're happy to talk with anybody about, a good way of tackling a particular issue and whether it's something, and we do a lot of different areas, but we don't do everything. So it's always good to learn. Most companies do this in some form, but we have noticed this was more prevalent in the 90s and the knots. I think my personal theory is it's a little bit of an echo from sequestration, where a lot of the thinning of the overheads took away the architects that were sitting on overhead to help with proposals, and so you sort of lost some of that talent to do some of this work. Obviously, every company's different, but it really is a bringing together of a couple different skill sets, such as systems engineering, finance, and program management to kind of put together a program, a program that closes and operates.
Hello, this is Vicki Kempf. I have a question.
Go ahead.
Hi.
Please.
It kind of goes to the question about vagueness of requirements and as it relates to incumbency, the approach to scope creep when you're an incumbent, is it more advantageous to ask more questions, to level set, or take advantage of the vagueness of the requirements if you're an incumbent?
Three.
That's a that's a great question, and we're always very picky about maintaining our independence, but we're really picky about it when we're dealing with an incumbent, because it's so easy to read into those requirements, and it's not that they're wrong. They probably are correct, but you got to be really aware of them. And whether you ask questions, whether you try to fix the requirements, whether you leverage the vagueness for your own benefit, has to be talked through.
Yeah, there's not a pat answer on that, but
there's not
but,
right.
But in general, and I think a lot of people on the call might agree, we don't like our clients asking questions when they're the incumbent in particular, unless they're trying to shape it, right? And because we want them to take advantage of the things they know, that the other people don't know. But at the same time, that vagueness can also help a non-incumbent, because the incumbent knows what it takes, and they know that the way the government wrote the requirement tends to take their competitors down a path that's going to be less expensive. It's not right. It's not reality. It's not what the government wants, but that's not when they put in the RFP. And often our incumbent clients are saying, what do we do? I mean, this takes 100 people, and the way
We
this thing is
execute
written,
at a higher cost. That's exactly my
yeah,
point.
you can't
It's a
do it.
common
So
problem.
that's right. And
Yep.
you don't have much choice. You have to bid it to win it.
Right.
You just have to do that and then fix it later.
Right, and be conscious of all of it. I mean, no unintended premiums. No, if you're gonna bid something you believe is going to be higher in a particular subsystem, you need to ghost it. You need to explain why. Okay, if somebody tries to do this with 70 people, here are all the issues you're going to have, and to a certain degree it becomes a visibility issue, but it is definitely something that has to be worked through.
And here's a pretty slick trick that'll go along with just kind of a pro tip, if you will, if you're not doing something like this. If you have this kind of analysis, and your team should have on complex development deals, cost volume is usually page unlimited. So that front end of the cost volume is a nice place to put things that you want your customer to see, the government customer to see, and you want them to not be able to unsee it. So I talked about, and I don't have one here, but I talked about a confidence curve. And confidence curves are great because it shows, it's like an S curve, right? And it looks like, okay, right in here, everything's fine. Up here, we have enough people, and we have enough time, and we have enough material, and everything's fine. This program's lovely. Down here, we got a problem, big problem. And we're showing that to you in our cost volume. And that's why we're not down there. That's why we put enough people and time and stuff up here to do the work. Now they know that now. They kind of can't unsee it. And then they go to the next proposal, and it's way low. And they're like, oh, I mean, that thing's going to blow up. So you can use a lot of these things as artifacts that can get put into the cost volume to help convince and show the government what reality is, and help ghost and block a competitor that tries to lowball into the non-reality world, or it's riskier, is what I want to highlight.
Okay. We have another question. Do you have any suggestions as to how to deal with inflation given the current state of the economy?
John, inflation's one of your favorite topics.
Yeah, we've certainly discussed it quite a bit. We've quite frankly, we've noticed the trend lately. We're seeing a lot more RFPs where the inflation is actually dictated. That is a problem. What we have been doing, and it's something to think about, is we have been using higher numbers, certainly higher than we used 5 years ago. We tend to use higher numbers this year and next year, and then sort of go back to more historic numbers, maybe a little lower than historic. Is that right? Well, I'm not going to claim to be an economist, but it's defendable. It would be difficult for the government to say, well, you know, 3 years from now, we're still not going to be back to normal. Well, okay. I mean, so we tend to think about it that way, is show some deference and some risk assessment for the short term, but kind of assume a return to normal at some point where it'd be difficult for the government to assign a weakness. Because ultimately, that's a lot of times what we're thinking about is, will this cause a weakness or a significant weakness?
And always keep in mind the type of CLIN it is. Is it a cost reimbursable CLIN or a fixed price?
Right. And one other point there. Think about how the contract type and how the information is provided. Because if they're T&M rates where the salaries aren't necessarily completely visible, that kind of leads you down one path. If they ask for a comp plan and they want to very clearly see what you're going to be paying the people, well, that takes you down another path. So, what does the RFP say about staffing risk? All that sort of thing has to be accounted for. There's not a generic answer.
Hey, but John, along those lines, just to kind of round this out, let's say you had a 10-year program. What would you put in for labor inflation now? How would you treat it? Not necessarily the numbers, but now and in the midpoint and toward the end of would it be the same escalation, or what would you do with it?
Oh no, I'd probably put in higher numbers for the first 2 years, maybe 3, maybe even a little bit more. But then I would try to go back to more historical numbers, closer to 2, for the remaining of the contract, and basically make the claim that
And that will make a tremendous difference. The power of compounding, right, over time on a 10-year program, 2 or 3%, over the years is dramatic. So that's a really important point.
Right. Any other questions? These slides will be distributed, I think, because
I think they'll be distributed to everyone.
Yeah, our contact information is on there, and we're happy to talk with anybody.
Contact is, just at the end of the slide deck. There's my contact information and Kim's or Kyle's contact information. And so if you don't have any other questions, thanks so much for your time. I appreciate the interaction. Maybelle, anything else on our end?
Nope, I don't have any other questions on the Q&A chat. Nope, that's all. Brenda, do you have anything to add?
Everybody, thank you so much for attending today. To Mike and everyone from his group, excellent presentation, excellent Q&A session, and we will be uploading this webinar onto YouTube. Okay, so everybody have a great day. Thank you so much.
Thank you. Bye now.
Thanks. Bye.